has a solution. So it's the set of matrices for which the LCP is always solvable. Can we? Is it in some form or another a positive class, a negativity class? But up to us really to define. As to the price Q, we will see a couple of important connections. Here's one important connection that I would like to make. If I can find it, or I put it down in my notes. Andre, where are you? Yeah, okay, so I'll recreate it. So the LCP QM has unique solution. For all Q in Rn, if and only if M is a P matrix. Okay. Now you may say this is related, and of course P is a subset of semi-positive. Okay. So in fact, and that's something that I will perhaps go into some more detail later on. It turns out that a matrix, I'll use A now, that A is a P matrix, okay, if and only if S inverse AS is semi-positive. So, I mean, there's a very nice direct relationship between these two observations with respect to solving the LCP. For all signature matrices S. So signature S is a diagonal matrix whose diagonal entries are plus or minus ones. Okay, that's called the signature matrix. So if you take all 2 to the n of them and you multiply, well, they're self-inverse, right? And you find all these signature similarities, we call them, of A, and you test and you see that they are all semi-positive, that's exactly as saying that A is a P matrix. And we will go into details here because this is an exponentially hard problem. And it leads to a lot of computational complexity questions that are unanswered with respect to solving the linear complementarity problem. So directly or indirectly, I'm not right in saying that Q is not present. It is indirectly present because many of the classes we mentioned imply the existence of a solution, imply the existence of a solution for all Q, or imply the existence of a unique solution. So there are many of them intersect the class Q very prominently. But I'm perhaps wrong, but the biggest disappointment I have in my understanding of this area is I don't really understand the class Q. You know, if you gave me a matrix and you told me, is it Q or not, I don't have a nice matrix theoretic test, even if it's computationally hard. I know there are some LCP type of tests, Karamardian's test or whatever, but it doesn't fit in my world very well, this class Q. And that's how I will promote understanding the class Q and putting it in the context of all these classes even if you cannot put it as a subset of anything, but find the intersection or find what happens with all these classes. I put it as I raise it as an interesting effort. Okay. All right. So now that we have this hierarchy with a little bit connected it to the LCP, we'll take a 10-minute break if that's okay, and come back and talk about the class SP, which is the king, right? It's the class for which everything we discover about applies to all of these classes. Okay, so it accomplishes this hierarchy, it accomplishes this unification, if you want, unifies all of these classes that we mentioned so far today. So if you have any questions, let me know now or save them for after our little break.
Just a few comments maybe after we return.
Yeah. You want me to put this back up?
Okay, so the thing is about the notation. Kotlpang and Stone is the book that you had prescribed. So in that book, the semi-positivity is denoted by S.
Right.
Yeah, and S apparently is for Steam K.
Okay.
And this EP, entry-wise positive, also appears in generalized inverses theory.
That is, sure, of course, yes.
EP projection matrices.
You're making an excellent point here. Every notation used on this page and this lecture today is local. It applies only to this presentation. Don't try to when you see P or SC or DN somewhere else, don't think it means the same. Okay.
Yeah, and a couple of comments.
So that's an important kind of disclaimer. Is that in every area, in optimization, in non-negative matrix theory, in analysis, things that are essentially the same have completely different definitions and notation. That's why I was kind of trying to kind of like carefully define what I mean by all these things. Yes. So in some of the books that you will see, the notation is different. Yeah. Well, you had another.
Yeah, regarding this positivity connection to Q matrices, I can cite a couple of them. One is given a non-negative matrix to determine if it is a Q matrix. It is a Q matrix if and only if the diagonal entries are positive. This is one nice result. It's not trivial at all. And another result which was proved by Sushmita that appeared in her thesis is that if you take a rank 1 matrix, then it's a Q matrix if and only if it is positive.
Yeah, I remember that. Yeah. So entry-wise positivity plays an important role. So so I'm trying to think now. So perhaps it will fit in here, right? Perhaps we can insert Q in this line. And anyway, it's something to think about. I have not thought about it carefully. So you said non-negative matrices are Q if and only if their diagonal entries are positive, right?
That's right.
Yeah. So therefore, positive matrices are Q matrices. Correct?
Yeah.
Okay, so therefore it will fit in between here, right? Because they're not necessarily totally positive, but they're positive. So and the totally positive are positive. So Q will fit in between EP and TP. For sure, and then perhaps in other places too, right?
Yeah.
And therefore, that makes them semi-positive as well, right?
No. The thing is,
Or they have to be non-negative.
Yeah.
Oh, okay. Yes, you're right. They don't fit. They don't fit in between.
You can have a Q matrix which is not entry-wise positive.
Right. Yeah, they don't fit in here. The intersection of So you're right. Yeah. Sorry about that. I misunderstood the criterion. Yeah. So yeah, they don't fit there. Yeah. So that makes my point a little bit more interesting. How can we insert Q matrices or maybe subclasses? You can certainly subclasses of Q matrices you can insert in there. But it remains a mystery class to me, and you know where I'm coming from, because in non-negative matrix theory, Q stands for something different. Q matrices are something different than how we define them there. And I am not sure that the two classes are totally unrelated. Anyway, we'll have the chance to discuss this more. Is it okay to take a 10-minute break?
Sounds good.
Excellent. So we'll be back. I don't know what time is it there.
Okay, maybe 9:10. It's almost 9.
Yeah. Okay. So in 13 minutes.
So